Alright, hey guys, this is Jacob3.mp4 here, and I'm coming back at you with another math tutorial. This is section 3.2, Graphing and Solving Radical Equations, page 179, 6a. So here our instructions are to solve the radical equations, A, algebraically, and B, graphically. And what we are given here is f of x is equal to root 2x minus 3. Outside of the root sign is minus 3 is equal to 0. So if we're looking for the x-intercept, what we want to do is, first steps first, we want to isolate the root. So I'm just going to write it out here. We have 2x minus 3, that's all under the root, minus 3 is equal to 0. So first thing that we can do is just add 3 to both sides. And that is going to give us root of 2x minus 3 is equal to 3. And then we will want to square both sides to get rid of our root. So there we go. So now we have 2x minus 3 is equal to 3 squared, which you guys know is 9. And then you're going to take the 3 and add it on both sides. So now you're left with 2x is equal to 12. Pretty basic from here. Divide both sides by 2. And we are left with x is equal to 6. So that means that our x-intercept, let me just change colors here. So for our graph, we will do it in red. I'm going to make a nice dot there. And we know that x 6. So our point is 0. So there we go. So there's that. And now we want to find the y-intercept. So what we do is we just set x to 0 for this. And you guys will find that this will actually be a pretty quick step. I'm going to do this in blue. And this is still doing it algebraically. So let me write that out. So again, what we want to do is just set this to 0. Well, actually we can add 3 on both sides. And now we have 2x minus 3 is equal to 3. So when you make x 0, you would get 2, 0, minus 3 is equal to 3. And obviously 2 times 0 is 0. So now you're left with the root of negative 3 is equal to 3. Well, that simply can't be anything because it just simply can't be done. You can't have a root of a negative number. So we know that there is, let me just write this here, there will be no y-intercept. So that'll be nice to keep in mind. So now that we have this graph pretty much, well, we don't actually have a graph, all we have is an x-intercept, but we have that algebraically. Now what we can do is we can look at some of the other key information that we know. So let me just get rid of these steps because hopefully you guys will know them pretty well. Use this eraser here. Get rid of all this. Get rid of all this. I'm going to keep that stuff there on the side though because that might prove useful. So let's go back to black here. So we can see our domain if we look at it. Oh, yeah, that was fat. Actually had that problem last time. So let's go back to that skinny. There we go. So there we go. So we have 2x minus 3. When we're looking at the domain, we look at what's in the root sign. So we have 2x minus 3 is greater than or equal to 0. And then add 3 on both sides. We have 2x is greater than or equal to 3. And then if we divide both sides by 2, we find that x is greater than or equal to 3 over 2, which is 1/2. So now that we know that, if we wanted to make a table of values to find the y values when we plug certain x values in for x, I know it's going to be fat again. So make a little table and make an x and make a y. This is how I like to do it. So since we knew that x had to be, I'm actually just going to write that down so you can keep this in mind. X has to be greater than or equal to 1.5 or 3 over 2. So since we knew that, a smart value to start off with is x is 1.5. So now what we want to do is plug 1.5 in for x. And so here we have 2, 1.5 minus 3. Oops, let me just do that. Minus 3. And then we want to find out what that is equal to. So we have 2 times 1.5, which is 3. So we have 3 minus 3 inside here, minus 3 is equal to what our y value will be. So then 3 minus 3, well, that's a little 0, minus 3 equal to what our y value will be. So that's just minus 3 is equal to y. So when x is 1.5, you know that y will be negative 3. So let me go back to red because that's what we're doing our graph in. So here's 1, and there's about 1.5x and then negative 3. So 1, 2, 3, and that's not really a point, but you pretty much see what I'm doing there. Going back to black. Now we know that x has to be greater than or equal to 1.5. So going down is not going to get us anything. So going up, if we use 2, we would have a new y value. I'm not going to do every single possible value for x because eventually there's going to be a lot. I'm just going to do a couple of key ones, and then hopefully alright, this is a heads up to anyone who watches it. If you use the eraser, you need to make sure that you select the skinny pen after because you're just going to have a fat pen. No one wants that. So we have 2 times 2 because now we're plugging 2 into our x value. Same equation as before, and now we're trying to find the y again. So this will be 4 minus 3 in the root. Minus 3 is equal to y. And 4 minus 3 is 1. Yep. Just checking my calculator because this is grade 12 and I really don't want to get anything wrong. So the square root of 1 is, well, it could actually be plus or minus 1. Minus 3. In this case, I'm just going to use regular 1. Just 1. So now we have 1 minus 3 is equal to negative 2 is equal to y. So when x is 2, y is negative 2. So let me just go back to red and let me plot this point. So x is 1, 2, y is negative 2. And there. And then the last point that I'm going to plot is going to be when x is 4, because then at that point you kind of understand the shape of the graph is going to look like. And especially if you just look at the function that you're given, you know that it's going to be a positive rational graph, or radical graph rather, sorry. So you already know the shape that it's going to make, and then you see that it's translated 3 and it's down. So you kind of already have a general idea of what it's supposed to look like. Let me make sure I go back. So the last one I said I was going to do is when x, is equal to 4. This will be the last one that I do. I think this vid's already getting a little bit long. So, and then the same steps are used, and obviously there's like a number of x values that you could plug in that are greater than 1.5. So 2 times 4, 8 minus 3 minus 3. Oops, forgot an equal sign over here. Is equal to y. So this is the square root of 5 minus 3 is equal to y. And you find that the answer is negative 0.7. is equal to y. There's some ugly steps in there, so I'm just going to leave that out. So negative 0.7. So then 1, 2, 3, 4, and then negative 0.7 down. So it's just kind of have to eyeball that. So that's kind of what that's going to look like. And then your graph is kind of just going to look like that, and make an arrow there because that's what that looks like. So here we go. So that's what your graph looks like. Obviously, from doing it algebraically, our point does actually work. And actually, I am going to show that because that's an important step as well. So that's going to be the last point that I do plot, just to tie it in nicely to end the vid. So it is going to, we're going to do 6. It's going to be the last. I need to heed my own advice. Alright, so 6 is the last one that we're going to do, and then I'm not going to have any more problems with this fat pen. Minus 3. So 2 times 6 minus 3 on the root sign, minus 3 is equal to what our y value will be. This is 12 minus 3, and then outside the root sign. So this is 9. 12 minus 3 is 9, and then the root of that is 3. Minus 3 is equal to y. So 0 is equal to y when 6 is x. So again, that was a bad 0. So that's the intercept. So pretty much you see how that all ties in nicely, how you can solve it to get this graph algebraically and graphically as well. Hope you guys enjoyed this nice little vid, and hopefully you guys learned a little something as well. All right, thanks.